Hello guys! Do you like to be skydiver? Do you want to understand how skydiver making these amazing movies? Really, we need to think about this lesson. It's so important lesson in the IGCSE exams, which is the changing of force and its effect on the velocity of the skydiver. Firstly, we need to understand the resultant force and the meaning of resultant force. Resultant force, which is the total force affecting on an object. If there is resultant force, there is acceleration and the object will accelerate in the same direction of this force. If there is no resultant force or the resultant force is equal 0, the object will move with constant velocity. Let's examine what will happen with the parachutist. When the parachutist is falling from the plane, as soon as he jumps out of the plane, the only force affecting now is the weight force, which is downward. The skydiver experiences a resultant force acting downward and equal to the weight. As the skydiver falls, air resistance acting upward. However, the weight is greater than the air resistance in the beginning of the trip. However, the resultant force is still downward, and the skydiver continue accelerate toward the ground. Due to this acceleration, the skydiver velocity will increase. At a certain point, when the air resistance balance the weight, which means the weight is equal to the air resistance, velocity stays constant, where the resultant force is equal 0. We call this velocity the terminal velocity. Velocity which is so high, and the skydiver will die if he hits the ground at this speed. And now this skydiver will start to open his parachute. Now the skydiver opening his parachute, and the surface area increases, which causes the air resistance to massive increase. At this point, air resistance is greater than the weight. So the object will experience a resultant force upward, and this will cause the parachutist to decelerate, or its velocity will decrease. When the velocity will decrease, the air resistance also will decrease. At the same point, again, air resistance balance the weight at a low velocity, which is called the lower terminal velocity. Lower terminal velocity. Now it's safe for the skydiver to land and to hit the ground without the probability of dying. Let's explain this trip using the graph. And we are drawing a graph between time in seconds and the velocity in meter per second. As soon as the skydiver jumps out the plane, the only force is the weight force, and the skydiver accelerates toward the ground. As point A, or point 1. At point 2, the skydiver falls and air resistance started to act. Weight is still greater than air resistance, so the skydiver will continue to accelerate and its velocity will increase. As the velocity will increase, the air resistance also will increase. As point 3, when the air resistance much increased to resistance to balance the weight at point 4, here we have the terminal velocity, which is the constant velocity when the weight and the air resistance will be balanced. At this point 5, the skydiver opened his parachute and the surface area much increased and the air resistance massively increased. At this point, started to peak down when the air resistance greater than the weight, and the resultant force will be upward acting, and the skydiver now decelerating and his velocity falls. At this point, because velocity decreased, the air resistance also would decrease, and at this point air resistance will balance the weight, and again the object or the parachutist will have a constant terminal velocity. We call it the lower terminal velocity, and finally the skydiver can land. The same concept can be applied for skydiver, where its weight is downward and the air resistance is upward, or with the shark, if it will move up to the sea and there will be drag force upward and its weight downward. The same concept also can be applied for a car moving horizontally, where the motor force is forward and the air resistance also is backward. Now, let's have example from the IGCSE exams. This diagram shows the vertical force acting on a ball as it falls vertically through the air. So we have air resistance upward and weight downward. The ball doesn't reach terminal velocity yet, which row describes what happens to the resultant force on the ball and what happened to the acceleration of the ball as it falls through the air. Resultant force, acceleration. Okay, firstly, let's think about it in this way. What we will describe to what will happen to the resultant force on the ball and what happened to the acceleration. Of course, we know that resultant force and acceleration are much related. If the resultant force decrease, acceleration will decrease. This could be 1. answer. If resultant force decrease, acceleration increase, and this is not true. Increase and decrease, this is not true. Increase and increase, this is true. So we have two possible answers because resultant force directly proportional to the acceleration. Okay, we need to know which situation is this. The diagram shows vertical, it's not yet reach the terminal velocity, which means the resultant force is not zero, it's a changing. Okay, changing in what situation? What happened to the acceleration of the ball as it falls through the air? It's fall down, which means the resultant force is falling down. Of course, air resistance, it's not yet, which means we still in this area of the graph. In this area of the graph, when the resultant force, can you see the velocity with time, or its acceleration, there will be acceleration. So in the beginning, of course, weight is greater than air resistance, but the weight and the resultant force as this reaches the ground, its speed is increasing until reaching the floor, which means that the resultant force is increase and also the acceleration increase. So answer D is the right answer. Good luck and see you in the next video. Mr. Ahmed Al-Zuhairi.